welcome to The Explainer. I am absolutely thrilled you're here today because we are taking a massive deep dive into Chapter 3 of the incredible book Monotony by Ariel Scisney. This chapter is simply titled, Where Are You? And we're going to answer that by lifting off from Earth on a full-blown cinematic cosmic tour. We're going all the way to the edge of the visible cosmos to tackle some truly mind-bending scales, the absolute nature of light speed, and your completely unique position in space-time. So let's kick this off with a question that might just shatter your baseline reality a little bit. Have you ever been in the exact same place twice? Now, your immediate instinct is probably to say, well, yeah, of course. I sit in the same chair every morning, I sleep in the exact same bed every single night. But from a cosmic perspective, the answer is a definitive, absolute no. You have literally never, not even for a fraction of a millisecond, occupied the exact same space twice in your entire life. And to really wrap our heads around why that is, we have to look at how our home is actually moving. Okay, let's dive into this crazy corkscrew motion. Think of space like the air around you. If you throw a rock straight up, by the time it comes down, the Earth has completely moved out from under that original exact spot in space. Because first, the Earth is tilted on its axis and spinning like a top. Second, it's constantly revolving around the sun. Third, the sun itself is drifting through the Milky Way galaxy. And fourth, this is the crazy one, our entire Milky Way galaxy is currently hurtling on a massive collision course toward the Andromeda galaxy. So, because the Earth is moving around the sun, while the sun is moving through the galaxy, our planet traces this giant continuous spiral or spring shape through the void. Everything is in constant flux. You are literally always traveling into brand new, uncharted cosmic territory. Section 1. The Earthly Measuring Stick. Now, to truly comprehend the distances we are about to travel, we can't just throw out massive numbers right away, right? It's beyond human comprehension. So we need to anchor ourselves first. We need a totally relatable earthly measuring stick, something you can actually visualize from your daily life before we zoom out into the deep unknown. Let's start with your own vision. Depending on your height and where you're standing, the average human can see about 3 miles, or roughly 5 kilometers, out to the horizon, right where the sky meets the ground. Okay, that is our baseline. Now take that visual distance and compare it to the total mathematical circumference of the Earth, which is roughly 24,000 miles. But here's the thing, even the circumference of the entire Earth is far, far too small a metric for the universe. We need a totally new measuring stick to bridge our earthly reality to the cosmic scale. And this brilliantly illustrates our ultimate tool, 299,792,458 meters per second. This is the speed of massless particles. It is the absolute hard speed limit of the universe, more commonly known to us as the speed of light. Because the speed of light is a measurable, finite constant in a vacuum, astronomers don't just use it as a measure of speed, but as our primary measurement of distance. To put that staggeringly huge number into perspective, if you could somehow travel at the speed of light, you wouldn't just cross that 5-kilometer horizon instantly. You could actually travel around the entire circumference of the Earth a little over 7 times in a single second. 1 second. Literally, just say the word 1, and light has circled the globe 7 times. It's wild. So when we talk about light seconds, light minutes, and light years, despite having the word year in there, we are talking about distance. We are talking about exactly how far that incredibly fast beam of light can travel over that specific amount of time. Section 2. Leaving our solar system. With our measuring stick firmly in hand, it is officially time for liftoff. We are leaving the Earth behind. We're pulling back the camera and beginning our true spatial zoom-out sequence, leaving our entire solar system in the dust. So here is our cosmic zoom-out timeline. Remember, light wraps around the Earth 7 times in a second, right? At that exact same speed, it takes a little over 1 light second to reach our moon. Suddenly, the scale grows exponentially. To reach the sun, it takes 8 light minutes. Zooming out even further, past all the gas giants, we hit 13 light hours away. This is the heliopause, the actual bubble of the sun's gravitational and radiation influence. It is right here that we pass the Voyager probes, literally the farthest machines ever launched by humanity. Continuing our journey out, we see the entire Milky Way, an expanse spanning roughly 100,000 light-years across. And crossing the vast, empty void to our nearest galactic neighbor, Andromeda, that takes a staggering 2.5 million light-years. Section 3. The Cosmic Neural Web. As we leave the individual galaxies behind, the visual structure of space completely transforms. We are now entering the realm of deep space macrostructures, stepping back so incredibly far that entire galaxies become nothing more than tiny glowing specks of sand in the dark. Now, what's really interesting about this slide is the overarching shape everything takes here. It's fascinating. We start with the local group, which is our immediate cluster of galaxies still bound together by gravity. Zoom out further, and we find we're part of the massive Virgo supercluster. But out here, in the deep void, dark energy begins to overcome gravity, literally constantly spreading these structures apart. We also see field galaxies, these beautiful blue spiral systems drifting entirely on their own. But when you look at the grand overall shape of these clusters and superclusters, they form these long filaments, webs, and nets. Actually, they breathtakingly resemble the neural networks of a human brain, forming this sprawling, interconnected cosmic web all across the blackness. Section 4. Edge of the Visible Universe. We are approaching the grand climax of our explainer. We've traveled past planets, past stars, and through neural webs of galaxies to head toward the absolute limit. 46 billion. That is a staggering, frankly overwhelming number of zeros to process. This is the radius of our visible cosmic bubble. We are currently 46 billion light years away from Earth. Because the speed of light is finite, remember, it takes time for light to travel. That means we can only see as far as light has had time to travel since the universe actually began. We literally cannot see past this distance because there simply hasn't been enough time in the entire history of the universe for light beyond this point to reach us. This is our cosmic wall. But at this wall, we don't just find empty blackness. We find the cosmic microwave background, or the CMB. Because looking far out into space means looking back in time, seeing this wall means we're looking at the universe exactly as it was when it was just a tiny baby, only 300,000 years after the Big Bang. Before this point, the universe was so hot and so incredibly dense that it was this opaque plasma. Light literally could not move through it. The CMB is the leftover radiation from the exact moment the universe cooled down enough for light to finally travel freely. And here's a totally mind-blowing fact for you. If you've ever turned on an old television or radio and seen or heard that fuzzy black and white static, a small percentage of that static is actually your antenna picking up the ancient, stretched-out light from the very dawn of creation. How cool is that? Section 5. Center of Space and Time. Man, what a journey. From the 3-mile horizon of Earth all the way out to the static edge of creation 46 billion light years away. It's enough to make anyone feel incredibly, incredibly small. But bringing you back home to your current position right now reveals one final, deeply empowering truth about your place in all of this. So the crucial point is how we actually misunderstand the Big Bang. Most people picture it as a tiny egg exploding outward from a single point into a giant, empty, dark room. But actually, scratch that. That's not what the science shows at all. The universe is likely infinite, and it is expanding uniformly, kind of like stretching a rubber band. Space-time itself is what is expanding. Because the universe is infinite, every single point was infinitely close together at the beginning, meaning every single point was the singularity. There is no edge to measure from, which means there is no central point you can point to. And therefore, mathematically and observationally, every single point in the universe is the center. You, sitting right there wherever you are watching this explainer, are the exact, absolute center of your own 93 billion light-year wide visible universe. As we conclude this massive cosmic tour, wrapping our minds around our own center in this infinite, sprawling expanse, I want you to consider how you process this new reality. To cap off our themes today of sheer scale and continuous learning, think of it this way. The book is the source code, the tutoring is the training, AI is the runtime, the portfolio is the output. Take this completely new cosmic perspective as your source code, run it through your own mind, build your portfolio of knowledge, and never, ever stop looking up. What will you do with your place at the very center of the universe? Thank you so much for joining me on this explainer. Keep exploring.